Hello everyone, my name is Pipin Abraham and in today's video we are going to talk about concepts of critical angle. It's basically a small topic. We are going to cover that in this particular video. So without wasting any more time, let's get started. Okay, let me start with a simple example. Imagine that this is basically a swimming pool, although it does not look like a swimming pool. Imagine this blue color represent the water inside your swimming pool, right? And let's assume that there is a small bulb which is like nearly at the bottom of the swimming pool and it is being lighted up, right? So what is going to happen here, the moment you light this bulb which is like almost at the bottom of this swimming pool, what is going to happen? So let's say, let me try to trace the light here. Obviously one light will go perpendicularly just like this, right? And obviously you have to understand that here we have water as my medium, right? So here I have water as my medium and this is my denser medium, and here I have air as my medium which is like rarer, right? Okay, so basically what is happening, your light is going perpendicularly out, like this is just one of the case. So because it's going perpendicularly, there will be no refraction for this particular light. Is that a yes or no? Right? Okay, now what will happen if your light will go at some angle? Let's say light is going like this, and let's say this is my a point, right? So at a point, obviously the first thing is you will very quickly make the normal, right? So we have made them normal. This will be your angle of incidence, and obviously we are going from denser to rarer medium, right? So basically we are in your denser medium and we are entering the rarer medium. So your light ray, what's going to happen, the light ray will bend away from the normal. Is that a yes or no? Right? Okay, great. Very similarly, if you increase your angle of incidence, let's say you increase your angle of incidence by some more angle, what is going to happen? Again you make a normal, right? Again we are going from denser to rarer medium, right? And that means your angle or your ray is going to bend further away from your normal, something like this. Yes, okay, great. Let's say you increase it further. Let's say you increase your angle of incidence further, right? So if you increase it further, what is going to happen? Again a normal, the light ray will bend further away from the normal, something like this. And if you keep on doing that at one very specific angle, what is going to happen? Your angle or your ray is going to bend in such a way that it is going to reflect along the surface. Is that a yes or no? And very similarly, same thing is going to happen here also, right? So let's say this was the angle for which what happened, your refracted ray is at the surface or at the interface, right? Now this angle of incidence inside your denser medium is what you call as your critical angle. This is what you call as your critical angle. You can represent this by C or you can represent this by IC, right? You have to understand, for your critical angle, your angle of refraction is 90 degree. Can you guys see that? Your angle of refraction is 90 degree. Is that a yes or no? Right? Okay, so let's try to understand what actually is your critical angle. All right, so critical angle, which is represented by C, or in some cases you can write it IC also, right? Okay, so critical angle, it is that angle of incidence inside denser medium for which your angle of refraction is 90 degree. Very important. Inside denser medium, it must be from, so your light ray must go from denser to rarer medium, then only this can happen, then only your light ray can refract at the interface, right? This is very important, right? Okay, there is a very common question, what will happen, sir, if you increase your angle of incidence further than your critical angle? Well, what is going to happen if you increase it further? Your light ray is going to refract reflect back in the same medium. Now that is what we call as a total interreflection, which is again a topic for next video. So stay tuned. In the next video we'll talk about total interreflection, right? So this video is purely based on critical angle. All right, great. So what is the critical angle? It is the angle of incidence inside denser medium for which your angle of refraction is 90°. Very good. Okay, so let's very quickly see here. So let's say I have this interface over here. So below this interface I have a denser medium, and above this I have a rarer medium. All right, great. So according to the definition, it is that angle of incidence inside denser medium, right? So basically I have to start from the denser medium. So I have started from the denser medium. Let's say this is my incident ray I dot r, right? And let's say this point is some a, right? Okay, next step, very quickly I will make the normal here. Great. So this is what your angle of incidence, right? Okay, great. It is, so basically we are talking about critical angle. So let me just say this is your critical angle, right? Okay, great. So it is that angle of incidence inside denser medium for which your angle of refraction is 90°. Your angle of refraction is 90°. Your angle of refraction is 90°. That means the angle between your refracted ray and your normal must be a 90°, right? If that is true, then this angle is what you call as your critical angle. Yes or no? I hope you guys can understand that, right? It's pretty simple concept. Sometimes it's written as IC, sometimes simply you can write it C also. It's up to the convenience, up to you, right? Okay. So what is the condition here? Two important conditions which you have to understand. Number one, like I said, light ray must travel from optically denser medium to optically rarer medium. So light ray must travel. So for example, you can see the light ray is traveling from denser to rarer, then only this can happen. Again, in this example, light ray is traveling from denser, that is your water, to air, right? Then only it can happen. Is that a yes or no? Great. Now I'll just copy this and let's try to do some mathematics over here. Just copy this. Okay, great. So I'll just copy it here. Great. Now what I'm going to do here is I'm going to apply Snell's law at point A, right? So very quickly apply Snell's law at A. So you apply Snell's law at A. So the moment you apply Snell's law at A, how you can write it here? You can simply write it here. First of all, denser medium, that is nu2 times sine of critical angle, that must be equals to, yes, for the second medium it is nu1 times sine of 90°. Is that a yes or no? So I can just write that here. Nu2 sine of critical angle is equals to nu1 sine of 90°, right? Okay, now very important, what is the value of sine 90? The value of sine 90 is actually 1. Yes, the value of sine 90 is 1, right? Okay, great. This is nu2 times of sine of critical angle. This will become nu1. Is that a yes or no? And I can write it, sine of critical angle is actually equals to nu1 upon nu2, right? Okay, and you can simply write critical angle is basically written as sine inverse nu1 upon nu2. Yes, I hope you guys can understand this, right? Okay, now this can also be written as nu12, or you can write it 1 upon nu21, right? So both the things are true, or you can write your critical angle as sine inverse of nu12, or you can write it critical angle sine inverse 1 upon nu21. Is that a yes or no? I hope you guys can understand that, right? Okay, so if that is true, let's very quickly do a simple question and just understand this concept, right? Okay, the question is, a bulb is placed at the depth h inside a swimming pool which is filled with liquid with refractive index nu. Great. Find the radius of circle through which the light will emerge. All right. So what is going to happen? So let's just quickly make the things, right? So let's say this is the interface of swimming pool and air. So here I have air, right? And here I have water. All right, and let's imagine here I have a bulb which is like glowing, right? Okay, okay, I do have a bulb. So this is the bulb. Okay, it's huge. Let me just reduce the size. All right, great. So I have this bulb glows. So what is going to happen? Obviously we just know, uh, first of all, let me just make the normal incidence here, right? Okay, so the light ray which is like going normal will go like this, and obviously let's say this is my critical angle at this point. Let me just say this is my point A. So at this particular, you know, at this particular, this is my critical angle, and for this your angle of, you know, I should say the angle of refraction is 90 degree, and your refracted ray will be along the interface, right? Same goes for this one right here also. All right, so let me just very quickly make, so your refracted ray will be along the, this is your incident ray, and refracted ray will be along the interface, right? All right, great. This is your again critical angle, and this is 90 degree. I hope you guys can understand that. Right now, if you clearly see it, you will actually observe light coming out of the swimming pool in a circular fashion, right? Why it is going to, you know, obviously after that, after this, the light, after, if you increase the angle after this, the light is not going to, you know, clear the next interface. It is going to be reflected back in the same circuit, which in the same medium, which we are going to study in the next video. That is your total interreflection part. But you guys can see the light will come out as a circular part, right? And in the question is asking us to find out the radius of that circular path. You have to find out the radius, the value of r, right? Okay, great. Now you have to understand that, let's see what are the things that is given in the question. It's given that the depth is h. All right, so this will be your h, right? Okay, great. Now you tell me, if this angle is critical angle, then can I say that this angle is also critical angle? Is that a yes or no? See, you guys can see there is a Z formation and these two are parallel, so this angle must be critical too, right? So let me just write it here. This is your critical angle. Very similarly, this is also your critical angle, right? Okay, great. Now how we can find out? Now before I find out, let's very quickly apply the Snell's law at point A. So where is my point A? This is my point A, and apply Snell's law there, right? So apply Snell's law at point A. So when you apply it, you guys can see in the question it is given that the water has a refractive index of nu, air has a refractive index of 1. Don't have to worry about that, right? So you can simply write that thing. Nu times sine of critical angle is equals to, yes, you tell me, 1 times sine of 90 degrees. Is that a yes or no? Or I can simply write this thing as, this will be sine of critical angle will be equal to 1 upon nu. Is that a yes or no? Or I can simply say I critical will be equals to sine inverse 1 upon nu. So this is one thing that I know. These two equations are very important. Sine critical angle is 1 upon nu, or I critical angle is sine inverse 1 upon nu, right? Okay, great. Now let me very quickly name this. This is my A, this is my O, this is my B. All right, now very quickly look at in triangle AOB. Look at the triangle AOB. Can you guys see AOB? AOB, this triangle we are talking. So this triangle is right angled at O, right? This triangle is right angled at O. I hope you guys can see this triangle is right angled at O. Yes, okay. So if it is right angled at O, tell me what is the value of tan critical angle. Tan critical angle can be represented as, it's basically a ratio, right? So you can write it perpendicular upon base. Yes or no? So this is your triangle and this is your critical angle. So tan perpendicular. So this OA will be perpendicular And what is the base? Base is basically OB. Is that a yes or no? So I can write this as OA upon OB. Yes or no? Okay, now you tell me, what is your OB? So if you see, your OB is basically the radius that we wanted to find out, right? Yes or no? So I can write it here. Tan critical angle is basically radius R upon, yes, what is your OB? Can you guys see here? OB is basically the height or the depth of the pool. Yes or no? Which is given as H. So very quickly I can write it H. Is that a yes or no? So your R upon H is actually equals to tan of I critical. Or you can further solve this. You can write your tan as sine critical upon cos I critical. Is that a yes or no? Right? Okay, great. Now we also know you can write your cos IC as root of 1 minus sine square IC. I hope you guys can understand that, right? You can write it like that. Yes. Okay, so instead of cos IC, I will write it R upon H is equals to sine IC upon root of 1 minus sine square IC. Right? Great. Now let's solve it further. We will get R upon H is equals to, now sine IC is something which is known to me. What is the value of sine IC? You guys can see sine IC is 1 upon nu, right? So I'll just put that there. 1 upon nu upon, yes, root of 1 minus 1 upon nu whole square. Is that a yes or no? All you have to do is solve it, right? This is R upon H is equals to 1 upon nu divided by, you take the LCM down there, this will be nu square minus 1 upon nu square, and the entire thing is under root. You will get 1 upon nu upon, yes, you will get root of nu square minus 1 upon nu, right? Nu and nu will cancel out, and your radius will be actually equals to H upon root nu square minus 1. I hope you guys can understand, right? So radius, so what is this H? H is basically the depth of the pool. What is nu? Nu is the refractive index of a denser medium. Is that a yes or no? So this is how you can actually find out the radius. I hope you understood the video. I hope you understood the video regarding critical angle. I hope you know how to calculate your critical angle now. If you have any doubt, you can ask me. You can comment it down in the comment section. That's all for today. Thank you and have a nice day.